The experiment aims to demonstrate the effect of soap on pepper floating on water. The experiment will explore the concept of surface tension. Surface tension allows light substances like pepper to float. Soap disrupts surface tension, causing the pepper to disperse. Gather the necessary materials for the experiment. A clean bowl will serve as the primary container. Water is required as a base liquid for the experiment. Black pepper will be sprinkled onto the water's surface. Liquid soap is needed to demonstrate surface tension disruption. Arrange all materials on a table for easy access during the demonstration. A clear bowl is selected to ensure maximum visibility of the filling process. The bowl is placed under a water source, such as a faucet or pitcher. Water is carefully poured or released into the bowl. The filling continues until the desired water level is reached within the bowl. Begin by evenly sprinkling black pepper across the surface of a container of water. Ensure the pepper is distributed in a thin, uniform layer for optimal demonstration. Observe that the pepper particles float on the water's surface without sinking. This floating effect is due to the surface tension of the water. The pepper is not dense enough to break the cohesive forces between water molecules. Therefore, the pepper remains suspended, illustrating the concept of surface tension. Water surface tension allows small, lightweight objects to float. The pepper floats due to this surface tension. Surface tension is caused by the cohesion of water molecules. This cohesion creates a thin, elastic-like layer on the water's surface. Liquid soap is introduced as a substance capable of altering water's properties. Specifically, liquid soap acts as an agent to disrupt the surface tension of water. Surface tension is the cohesive force that causes water molecules to stick together. Soap molecules interfere with these cohesive forces between water molecules. This interference reduces the water's surface tension. The reduction in surface tension allows water to spread more easily. Begin by selecting a liquid soap suitable for the intended cleaning task. Dip the tip of a finger into the liquid soap container. Ensure only a minimal amount of soap adheres to the fingertip. This controlled application prevents overuse and waste of the soap. The small amount of soap is now ready for targeted application. Begin by lightly coating a finger with soap. Prepare a dish of water with pepper floating on the surface. Gently bring the soapy finger towards the center of the water. Make initial contact by touching the water's surface. Observe the reaction of the pepper as it moves away from the soap. Pepper particles, when introduced to a liquid surface, exhibit a rapid dispersion effect. This phenomenon is characterized by the immediate movement of pepper away from the point of contact. The dispersion occurs swiftly, creating a visible clearing around the area where the pepper was initially placed. This reaction demonstrates the surface tension dynamics and particle interactions within the liquid. The pepper rapidly disperses from the center of the bowl. This dispersion occurs quickly upon the introduction of a catalyst. The movement is directed outwards, towards the edges of the bowl. This demonstrates a visible reaction to a specific stimulus. The experiment concludes, revealing the post-reaction state within the bowl. Notice the altered distribution of pepper within the water. The pepper particles are no longer evenly dispersed across the surface. Instead, the pepper has aggregated and clumped together. These clumps are primarily located around the edges of the bowl. This redistribution demonstrates the effect of the reaction on the pepper's surface tension. Surface tension is a property of liquids that allows them to resist an external force. This phenomenon is primarily due to the cohesive forces between liquid molecules. In water, these cohesive forces are particularly strong because of hydrogen bonding. Molecules at the surface experience a net inward force, minimizing surface area. This inward force creates a skin, or tension, at the surface of the water. This surface tension allows water to support small objects or resist penetration. Water molecules exhibit strong cohesive forces, attracting each other. This attraction is due to hydrogen bonding between water molecules. At the water's surface, molecules experience a net inward pull. This inward pull creates a skin or surface tension on the water. Surface tension allows small objects to float on water, despite being denser. Soap molecules possess a unique dual nature that allows them to interact with both water and oil. This is due to their structure, which includes a hydrophobic end that repels water. They also have a hydrophilic end that is attracted to water. This combination of properties enables soap to emulsify oils and dirt, allowing them to be washed away by water. Soap molecules are amphiphilic, possessing both hydrophilic water-attracting, and hydrophobic, water-repelling, parts. Water molecules are cohesive due to hydrogen bonds, creating surface tension. When soap is added, the hydrophobic tails of soap molecules insert themselves between water molecules. This insertion disrupts the hydrogen bonds and cohesive forces between water molecules. The reduction in cohesive forces lowers the surface tension of the water, allowing it to spread more easily. Surface tension is a property of liquids that allows them to resist an external force. This is due to the cohesive forces between liquid molecules. Introducing soap reduces surface tension by interfering with these cohesive forces. As a result, water molecules spread apart more easily. The pepper initially floats on the water's surface due to surface tension. Surface tension creates a cohesive force between water molecules. Adding soap breaks this surface tension at the point of contact. This reduction in surface tension creates an imbalance in surface pressure. The higher surface tension around the perimeter pulls the pepper away from the soap. Surface tension is a property of liquids that allows them to resist an external force. This effect is due to the cohesive forces between liquid molecules. The introduction of soap reduces the surface tension of water. Soap molecules disrupt the cohesive forces between water molecules. Adding soap to the center of the bowl weakens the surface tension in that area. The surface tension at the edges of the bowl remains stronger compared to the center. Force vectors are visual representations of forces, showing both magnitude and direction. In this scenario, force vectors illustrate the forces acting on pepper flakes. These forces cause the pepper flakes to move outwards. Each vector indicates the direction of a specific force acting on a flake. The length of the vector corresponds to the magnitude, or strength, of the force. The combined effect of these forces results in the outward movement of the pepper flakes. Soap reduces the surface tension of water. A higher soap concentration results in a greater reduction of surface tension. Pepper flakes on water are displaced by the sudden decrease in surface tension when soap is introduced. Increased soap concentration causes a more rapid and forceful dispersion of pepper. The speed and distance of pepper movement are directly proportional to the soap concentration. The experiment's outcome is influenced by the liquid's surface tension. Liquids with higher surface tension may exhibit different behaviors. These differences could affect the observed phenomena. Using various liquids allows for comparative analysis of surface tension effects. Water temperature is a key factor influencing surface tension. Increased water temperature generally reduces surface tension. This is because higher temperatures increase molecular motion. Greater molecular motion weakens the intermolecular forces responsible for surface tension. Therefore, temperature variations can significantly impact the results of experiments involving surface tension. Understanding surface tension is crucial in the development of effective cleaning products. Surface tension principles help formulate detergents that can efficiently remove dirt and grease. In industrial processes, controlling surface tension is vital for coating applications. Surface tension affects the spreadability and adhesion of coatings on various surfaces. These applications demonstrate the practical significance of surface tension in everyday products and manufacturing. Further experiments can explore the properties of surface tension. One approach is to test various types of soap. Different soaps may exhibit varying degrees of surface tension reduction. Another approach is to experiment with different liquids. Liquids with different molecular structures will have different surface tensions. This experiment demonstrated the principle of surface tension in water. Surface tension is the property of a liquid that allows it to resist an external force. Pepper initially floated on the water due to surface tension. The addition of soap disrupted the water's surface tension. This disruption caused the pepper to disperse and move away from the soap. The observable effects clearly illustrate how soap weakens the cohesive forces between water molecules.